like I actually did the problem like I was supposed to.
Right.
Which one was that?
Number
We're
one.
talking about number 1.
Okay.
Buddy.
That's coming.
Yeah, I need to find my pen. Like I actually did the problem like I was supposed to.
Right.
No.
Which one was that?
Number one.
We're talking about number 1.
Why is that repeating?
I was wondering that as well. Maybe. Okay, I think it won't repeat now.
Okay. I was like,
For some reason, there's like another screen behind it, and it was a minute and a half behind or something.
Playing.
That's funny.
That's funny. Has anybody heard from Steve?
Oh, from who?
Steven.
I have not heard from him. Well, I guess we could probably start, though, because he'll probably be on in a minute or two, normally.
Yeah. Okay.
And so, Leah, how did you do number one?
Okay, so number 1 was really puzzling to me.
Yeah.
I was like, where are they getting the standard deviation?
That's how I could figure it out on the graph, but I couldn't figure out where they're getting like the number from.
So on that paper it says 2.2.2, and
Yeah.
that was the wrong thing. It's really 3.2.2.
Okay.
I'll try to see if I can share this screen.
Hi. So cute.
So can you see number 1 there?
Yes.
It's got it highlighted in yellow.
Mhm.
I was so confused and frustrated.
Yeah.
And then I saw the formula on number 2. And
Okay.
then as I was going through the reading, I found the actual formula in that 3.2.2.
Okay.
And so that gave us the deviation of the mean. Are those the right words? I think they are. So does that make sense?
Yeah. That does make sense.
So I'll stop sharing.
So I just want to make sure I knew how to do it, so later on
Yeah, I'm sure I'll need it.
I wasn't, more confused.
Are you typing something, Tracy?
Yeah, I'm texting Stephen.
Oh, okay. Were there any others on that we needed help with?
No, I understood all of them other than that one, and I think I was just trying to figure out where to put numbers.
Okay.
So,
Okay, so which other ones are we doing?
so we are on number 6.
Number 6.
Okay, Chloe.
That's right, 6. Curly hair.
There. So I guess I can start.
Okay.
Not to. So the mean score of all GRE scores is 150.8 with a standard deviation of 8.8. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean and then a standard deviation. So you need to find the mean and the deviation.
And
So-
it told us that was 150.8, right, for the mean?
Yeah.
And standard deviation of 8.8.
Sounds right to me.
I like the easy ones.
Yeah. Sometimes I think too much about it, and that makes it harder.
I agree.
So.
Mom?
I really liked that graph thing, the
Yeah.
normal deviation app or something like that.
Yeah, I know what you're talking about.
Good.
It took me a little while to figure it out. I was like, why is this answer double what it's supposed to be? But as I unclicked the blue, then I was like, oh,
You.
Yeah.
it's fun to learn.
Okay, and then part B. What proportion of the people who take the quantitative portion of the GRE will score above 165?
6.
And for me, I highlighted that above to make me
Six.
pay attention to what it was wanting.
Yeah. Okay,
Yeah, that makes sense.
You know, I can't hear because you're talking right in my ear.
Okay, so the z-score would be 1.6136.
Could be. Yeah, that's what it'd be.
Hey, Alyssa,
Uh-huh.
Steve just texted me and says he does not have a link in his email. How does he connect?
I'll send them one.
Okay.
Yeah. What, Chloe?
So if we put that 1.6136
Into the bottom boxes.
Chloe.
right into the normal probability applet that they gave us, the area comes up with 0.0533. And I would guess that would be the answer. So it would be like 5%, 5.3%.
Oh.
Yeah, if we just click that one part above our answer.
Yeah. Yeah, I don't need to make noises right now. Thank you, though. Oh, there you are.
Bye, Steven.
That's a lot to say. Okay, so you just did number C, or letter C. Is that what you're saying? Or were you on letter B still?
Yeah, that was B, wasn't it?
Yeah.
So the answer was.
Okay, so you're doing the second part of it.
Yeah, 0.523.
Yeah.
Okay.
Not to me.
Okay, so the C is if the student's score is the 10th percentile, what would their corresponding z-score be?
So if we put the 10% in the area,
Mm-hmm.
Or 0.1? 0.10, right?
yeah, 21.
So then it gives us 1.282. Or actually, it'd be a negative, right? Because it would be on the smaller end.
10th. Yeah, because it's the 10th percentile.
Are you doing that in that applet thing, or?
Yes.
Okay. And so where are you? So did you say you put the 10th% up in the area part?
Right.
Okay.
And then if you click off to the left side of what the z-score will be.
And is that where you put the 053 part there, or the 1.7?
Let me see if I can screen.
It's almost dead.
Okay, so can you see that?
And then the last three.
Okay, so that's where it's click the 0.10 there, and click on it.
Got it.
Okay.
Yeah. Because that's what I'm going as well.
Okay. Alright, so the next one, what is the quantitative GRE score for a student who scores in the 10th percentile? We just did that, didn't we?
Thank you.
No, because one was the
Just do that? Oh, okay, it's close to the same one. Okay. I'm sorry.
Which one are we guys doing?
We are on 6D now.
Okay.
Did you have any, no, I wonder if we should go A, B, and C.
I couldn't
You
understand
couldn't
you.
understand them.
Say that again.
Would you like us to go through A, B, and C again? We can, I'm sure. Okay. Okay, so A is just scored on a quantitative proportion from the mean. So the mean was 150.8, and the standard deviation, which is that weird little O whatever, is 8.8.
Okay.
B was what proportion of the people who take the quantitative portion of the GRE will score above 165?
So is that where you divide those two?
Yeah, you'd have, I use it on a spreadsheet. So you're looking for your Z-score. So your Z-score will be 1.6136.
Okay.
And do you need to know how we get that, Stephen?
So I'm gonna jump ahead. Is the answer 17.13?
For that one, no, it's not what I got.
Okay, then yeah, help me.
Okay. Okay, so the mean is the 150.8. And maybe let me see if I can share my screen. It's probably easier for me to do it that way.
Yeah, that's a baby.
Okay, I'll just have to explain it.
I can show it off to the spreadsheet, please.
Okay. First, start off with you try and find the Z-score. So you do the X, which is the 165, because they're trying to find out the GRA will score above 165. So 165 minus the mean, which is 150.8,
Okay.
and then you divide that by the standard deviation.
And can you see it, Stephen? I've tried to share it.
Give me 2 seconds.
Okay.
Yes, I do see it.
Does that help any?
Okay, so I just was not minusing the 150 from the 165.
Right.
Okay.
Okay.
Okay. I'll stop
Yes,
sharing.
that helped. Thank
Okay.
you.
You bet.
Okay, so that was the first part, and you can see on Leah's how she put the 1.6136 off to the right-hand side,
Okay.
and then, I'm sorry, Alyssa, that's just for
Poor thing. Do you want me to share that again?
Yeah, please, Leah.
Okay, one moment. Sorry. I don't want to be a screen hog. Okay, does that help?
Yes.
Okay, so how she's got it on the right, she clicked that on the right-hand side. Did you play with
Where it's
that thing at all?
So you're always going to have the positive on the right, the negative is going to be on the left.
Right.
Yeah.
And I
Right.
highlighted the above in yellow to remind me to put it on the the top side.
So this is similar to the batting average
Yeah, I think so.
diagram.
Yeah.
Am I right?
Yeah.
Yeah, really similar.
Right.
Mm-hmm.
Okay.
Yeah.
Okay. All right, so should we go on to the next one?
Yeah.
The next one said if the student's score is the 10th percentile, what would their corresponding z-score be? So if you went into the, what is it called? The normal probability applet, and on the area, if you put 0.100 and click on the left-hand side because it is the 10%, which is the low end, it will give you that answer.
And I can share that if we want.
So,
If I can get it.
can you explain that in English?
Yeah, here
That's
comes
the
the
best
screen
I can
share.
do.
Does this help, Stephen? So in the area, we put the 0.1 in that,
Okay.
and then that pops up with the z-score down here, and it's
Okay.
asking for the 10th percentile, which would be down low. So that's why this is only blue right here.
So, in that box, you're able to type it in?
Yeah, you can type that in. I'll see if I can find it on another screen and show
Were you able to
I
play with
have it on my
that?
screen right now. On the screen,
Okay, share it.
not on yours. Okay. Let me. Oops. Just find that. All right. There you see. Oh, mine just switched though. Let me change it. So it's like, did it change? There you go.
Yeah.
So were you able to play with that normal probability output?
I'm trying, and it's not.
Okay.
I'm clicking on it, and it's not letting me.
There's a spot in that reading where it
Yeah.
says to right click on the link and it can open that up. Let's see if I can find the page.
So, are you doing this on the actual homework? Or are you going to a different link?
It's a different link. It's in that 3.4. I'll share this screen. Maybe.
You showing him how to get to it, save it?
I'm trying to. Okay. In our reading in the 3.4, you see where we're at?
Yes.
There's this normal probability applet. And
Okay.
if you click on that, I'm not sure if it's going to show. Does it still show?
Yeah.
And then you can just type whatever in here. And there's the 0.1. And you can color these blue or uncolor them. And then it gives you your z-score in the lower boxes, or you can type in a z-score here. And it'll give you the area up top.
So I'm going to type in 1.000.
No, 0.10. Because it's the percentage.
That's right. So the z-score is 1.645?
Yeah, that's what it comes up to.
Okay.
Oh,
I got it.
1.6136, sorry. Oh, wait a minute.
1.282.
Yeah, sorry.
It's okay.
Getting ahead of myself.
Mm-hmm.
So I typed in 0.1000,
Okay.
and it just came up as 1.645.
Do you have any? How many blue things do you have?
2.
Unclick one.
Okay, you're going for the 10th percentile, so it'll be on the far left side.
Now I got 1.282.
Right.
That's it?
Yeah.
Yep.
So that you only want 1 click.
Well, whatever your questions ask.
Okay, that makes sense.
Above or below.
You guys are awesome.
Okay, so to finish that answer, we need to. Oh, actually, that one is finished, huh? Okay, I'm getting ahead of myself again. Okay, so this is where we're at, is what is the quantitative GRE score for the student who scores in the 10th percentile? So the GRE score, we would use the 1.282.
Then you times that by the standard deviation, correct?
Right. Of 8.8.
Yeah, and actually, I'm wrong when I keep saying 1.282 because it's actually a negative 1.282.
Yeah.
And I need to stop saying that.
And that makes a difference because I got the wrong answer. And I got the
It's
negative.
the lower 10%. It's lower,
Right.
so you have to subtract it from kind of the higher part.
Right, so we would take the 150.8 and we would plus the negative 1.282 and then we would times it by 8.8, which would give us 139.5184.
Yeah.
So if we round that, I mean, we're at 140, right?
Right.
So that's what the scores in the 10th percentile would be, if I understand that correctly.
I believe so.
Okay. Are you doing good, Steven?
Yes, I'm doing good. I'm just
Okay.
redoing it to try to make sure it sticks.
Okay. All right, so are we ready to go to 7?
Yes.
Okay. Okay, the mean speed of hydrogen at room temperature is 1,800 meters per second, with a standard deviation of 600 meters per second. Okay, so the first one, A, is, of course, the U is the 1,800 meters per second, and the standard deviation is 600 meters per second. Okay, so what is the probability that a randomly selected particle has a speed over 2,500 meters per second? So, I'm trying to plug this in.
So you're going to take your 2,500 minus the 1,800.
And then divide that by 600.
600, right.
Okay, so our z-score would be 1.1666667, right? Yeah, she agrees with me.
That's awesome.
Okay, so then do we need to go further with this?
Yes.
Or is that the answer?
I think this is where I was getting confused.
Okay, so this is where we need to plug that z-score
Of 1.1
into the, yeah, okay, hang on 1 minute. So the z-score needs to be down there at the bottom. What was that, 1.166?
Yeah.
7.
7.
Okay, so then the area should be 0.1216.
No.
I'm trying to find out exactly how we got the 1217. Is it
Okay.
the numbers in the bottom part and then we got the top number?
Yeah, we're looking for the Z-score to start off with, so we can get the area number with there. So with the Z-score, we take the 2500, because that is what the speed, the selected particle has a speed of 2500. So minus 1800, and then we divide that by 600, which was your standard deviation.
Okay.
Which gives us 1.1666667.
Okay.
Am I doing this right?
Yeah, it sounds right.
Okay.
I'm a little confused still.
Okay, let's see. Trying to find the right sheet to share with you, Stephen.
Oh, you
It probably didn't help that I didn't finish all the reading. I started it.
Well, Stephen, neither did I. But I watched the videos. If that helps.
Do the videos help more than reading, do you think?
I don't know, but today was presser time. I'm quite overloaded. I'm kind of foolish that way.
I think every day is that way, right?
Yeah.
Pretty much.
Now in my graph thing, it won't let me. It'll only let me put 3 numbers in.
Which graph is that? The normal probability outlet?
Yes.
Yeah, mine's only going 3 numbers out there also, so there's probably no sense in me putting 66667.
So did you just put 1.167?
Yes.
Okay, and then what did it? And then you just have the area for that. Okay, I see what I'm doing wrong now. I got it.
Okay. Stephen, how are you doing?
What did you say?
How are you doing? A good question.
So, yeah, I've typed this in, and I don't think I'm right.
You want to share your screen?
Yeah, that's what I think too. Share your screen.
Okay, let me see if I can do this.
That's what it's supposed to look like, correct?
Yeah.
Yeah.
This is right?
So
Well,
click on the right side of it and then click on the left side to. Yeah, there you go.
There you go.
So the answer is 0.966.
Well, you need to, in the Z-score part, put 1.167. Is where
Right
you.
here?
Yeah.
Yeah. Click. There you go. One point one six seven.
0.167?
1.167.
Chloe.
I can't hear you, is that right?
No,
There's
the
no one?
one in front of it. 1.167.
So then the answer is this.
Yes.
Yep.
So when we go to take a test, is this little applet going to be there?
That's a good question. I hope so.
I think any of the tools that we're supposed to use in our homework, I would think we would be using on our tests. if they want us to use them.
Okay.
At least that's what I would think.
Yeah, I think so too. Okay, so does everybody understand why that is why we went through it that way?
I think I'm starting to get it.
Okay.
Slowly.
Okay.
Yeah.
Okay, so we will move on. Which one are we on? C? Okay, so what is the probability that a randomly selected particle has a speed that is less than 25,000? Or 2,500, sorry.
So we would just click on the left part of the graph.
Yeah, I think so. Can't we just, if we've already got the right side of it, couldn't we just minus that from 1? Or would, well, it'd probably be easier just to, I don't know which way would be easier.
I think that way works too, Tracy.
Oh yeah, we can just click it. So either way, they're both pretty simple. Probably just clicking the two left sides of the normal probability is easier.
If it's less than 250, that would be the middle part and the end part, correct?
Yeah.
Okay.
So we get 0.8784.
Yeah.
Okay. Okay, so number D, what is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second? So we'll start off with, we need to find our z-score, right?
Correct.
Okay, so our z-score is negative 0.5.
Okay.
So it'd be on the left-hand side, right?
Yeah.
Okay, so if we click onto the left side and the negative 0.5, our area would be 0.3085, so 31.
Wait 1 second. Okay. So it'd be 0.3085.
Yep.
Okay.
Uh-oh. Okay, so we all good on that?
So after we do, so we're going to do 2,500 minus 1,800. Am I right?
Which one are you on?
C.
Well, did I read that wrong?
No, I thought we were done with C, but that's okay.
I thought we were done with.
Oh, okay.
Hold on.
Okay.
Oh, are we on D?
We'll go back up then.
Yeah, let's go back over C though.
Okay,
Well,
yeah,
okay.
because I might have confused it. Okay, so what is the
That's probably
probability
why I
that a
was-
random...
That's probably why I was
Randomly
confused. I
selected,
thought
sorry.
we were on C.
Okay. So what is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? So on this one, I just figured that we had already did the 2,500 over. So the rest of it would be under.
Oh, I think you lost me, Tracy.
Yeah.
Okay. Okay, so if we go up to B, what is the probability that a randomly selected particle has a speed over 2,500 meters per second? So we have that answer, right?
So our end answer is 0.1217.
For B, yes.
Okay. So then we're going to take that answer and go to C.
Well,
Did
yes. If you go onto your that normal probability applet
Okay.
and you click on the left two sides, the center one and the left one, and then click the right one where it goes away, it gives you your answer.
Okay. Okay. Gotcha. So C was the answer for C is 0.8783.
Yeah,
Is that right?
that's what I got.
Okay. And then down to D. Have you already done D?
No, we were starting it.
Okay, and then I goofed you up.
That's fine.
Right, so D was what is the probability that a randomly selected particle has a speed that is less than 1,500 meters per second. So we got our Z score, which was negative 0.5.
And do we want to know how we got there, Tracy?
The Z score? We've been doing the Z scores. Yes. Okay, so we took 1,500 minus the 1,800, which is the mean, and then we divided that by the standard deviation, which was 600.
Right.
And then we put the 0.5 down in the Z-score, right?
Yeah, off to the left-hand side.
And we want to know what was less than 1,500.
So would this answer be 0.3085?
That's what I got.
Yeah,
I got it.
correct.
Light bulb came on.
Yay!
Awesome.
Okay, thank you.
E is where I think I get really confused.
Yeah.
Okay.
And the only reason I know how to do it is because I was looking at the answer sheet, and it actually says that most groups will need help on this because it's a new concept.
Awesome.
Yeah.
So let's get some guidance from the answer sheet, I guess.
Okay, don't you just take your other answers and minus them?
Yeah, that's what it is. It's the answer from C and the answer from D minus, and that's the answer.
Okay.
But see, I would have thought that you're supposed to use a graph for it. And so I would have been really confused if I hadn't seen that.
The money, Dad.
It's Daddy.
So Alicia got me into that one. Hi, Chloe. Yeah, we don't do that. We'd love to go back there and see that. Fortunately, it's during the busy days of my work.
So we would take a 0.3085
Hang on.
and then minus.
I got 0.569.
So you said we subtract B from C, the
Yeah,
answer?
so the answer.
Yeah.
Okay.
So 8.878 subtract 0.3085.
No, that's good. Sweet. You too, bro. I'll see you soon. Right. Goodbye.
What is that? Nope.
So 0.569.
Can I get a hug?
No. The babies.
Yeah, Trace.
Turkey tacos. turkey tacos, but I haven't started yet. The turkey needs some roasting.
Okay. I might be lost on this.
You take your 0.878 minus your 0.3085. Or 0.8783 minus 0.3085.
Okay, and I got 0.5698.
Right.
Okay, so that's the answer to E?
Yes.
That's confusing.
Yes, so
It's
can
all
somebody
confusing.
explain why? It makes logical sense to do that, but I wonder if there's something, if there's a reason why.
No. I haven't.
Or you just do what you
Or is it
do.
because we figured out what was
I mean, on the answer sheet, it has a whole solution thing, but I don't know how to explain it.
Okay.
Do you want me to share the screen?
If you want to, or I can, either way.
Okay, can you guys see E up here now where I have what highlighted?
Yeah?
Yep, the solution of 1500 less than X. Less than? Yeah.
Mhm.
X is greater than 1500 and less than 2500. So that X less than 2500 is our 0.8783 because we already got the probability for that. I don't know if that's the right word, but that's the word I'm going to use. And then the 1500, we've already gotten that answer in the one supplied here. Or we got the X less than 1500. And that was our answer of the 0.3085.
Okay. I just hope they don't ask us that one.
Right.
Okay.
Okay, what are we on here?
All right. So which one are we on now then? Okay, so what is the third quartile of the speed of hydrogen at room temperature? Third quartile would be
Third quarter would be
75.
the fourth.
0.75 in the area.
Okay, and then you'd click all three, or would you just you just click
I think just the two light up when you put in 0.75.
Yeah, mine didn't. Mine was still over 75.
Mine automatically did it, so I don't know.
I got
Okay.
0.674.
Yeah, that's what I got too. Okay. Is that the answer for that?
So what did you put in the area part?
0.75.
0.75?
Yeah.
Okay, and then where did we get that? Or what number did...
Third quartile?
Third quarter, like 3/4, quarter of a dollar.
Okay, and then
That
that
makes
gives
sense.
us... Is that what you're saying?
What was that?
And then that gives you the z-score, which is 0.674?
Right.
Yeah.
Okay. That makes sense. I was...
But we don't have to. We don't have to put in the 2 zeros after the 75. We can
No.
just go to the tenths, or let's see, tenths, hundredths, and we're good, right?
Mm-hmm.
I guess when I type it in, it automatically adds 2 zeros anyways.
Yeah.
Yeah.
Okay.
Okay, so
And then is there more that we need to solve though?
yeah, it looks like
You have to look at the QQ
Mhm.
charts.
yeah. Okay, so we're supposed to look at these, and during your group preparation meeting, you will determine whether the data represents in these QQ plots are normally distributed or not. Record your answer for each graph, justify your answer. Okay, so does everybody have them pulled up?
I do.
Close.
Well, I'll take A. That one's easy. That's definitely no.
Definitely not normal. Is that what you're saying?
Yeah, not normal, sorry.
So, where is the QQ plot on this in the homework?
It's towards the bottom.
You have to scroll.
I have found it, but is there a diagram just kind of like the applet one?
No.
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 Okay.
Okay, so what do we think on B?
It's not straight.
I don't think it's
Not
normal
straight,
either.
and there's like just random.
Yeah, I think there's 2 randoms.
Yeah.
So not normal.
Mhm.
I would
So
say
you're
not
saying
normal.
A is not normal, or A is?
A
It's
is not
normal.
normal.
It
Okay.
kind of just goes straight up.
Yeah, it should be in a straighter diagram, I think.
So like D would be yes?
I
These
think
no, because there's like outliers, and then the curve's not. Yeah, it's like not a steady.
Yeah, it's kind of an S-shaped.
Mhm.
Okay.
Barely.
So then what would you say for C?
I would say it is.
I'd say it is as well because there's like kind of a pattern to it.
Yeah.
Okay.
I think the first 3 kind of throw you off a little bit, but I
Yeah.
think it's still normal.
So C is yes,
Mhm.
D is no. Is that what I heard you say?
And we haven't done D. I would say D is normal. I mean, that's a really good one for normal.
I like F.
Yeah, F is a perfect one. Yeah, definitely normal for F.
How about E?
Is there too much curve in that left, and then it goes up?
That's what I
very
kind of
high?
feel it might not be.
I think there's too much slope
Right.
from your mid-range right there. So if you actually put that on like a bell curve, your bell curve, it would really slope to the right. Does that make
I would
sense?
say no.
Yeah, I would say no also.
Okay.
Let's say
Yeah,
no.
there's just too many dots on that left-hand side there.
Yeah, it's like
That's under the 0.5.
Alright, that makes sense.
And I think that was kind of a tricky one.
Those were pretty tricky. There's quite a few in there.
Okay, I think that's it for the preparation.
Now to the quiz.
Yay!
Oh, I'm not there yet. I better get there.
Okay, once again, I'll get answer number 1 and 2.
You're a cheater.
Yes.
Stop it. I'm still not there, so.
Just give me 1 second. It logged me out, so I have to log back in.
Total area under a density curve must equal 1. I like that one.
I'm on it.
Yeah, now who's cheating?
Me? I know the answer to
I
that
can do
one.
number 4.
Okay.
Because under certain circumstances, a density curve can drop below the x-axis. I thought that would be false.
Hold on, where are you guys at?
In the quiz.
Yeah.
Which one is this?
5.
5.
Why?
Group meeting.
Because I almost feel like there might have been at the beginning where it said.
Density curve can drop below the x-axis.
Mm-hmm.
Where'd my homework go?
Let me.
So you're saying it could
Yep,
go
it
negative?
says all density curves, including normal density curves, have 2 basic properties. It always equals 1, and the density curve always lies above, on or above the horizontal axis. So that would be false.
Okay.
False.
Okay, we'll learn something there.
Normal density curve is symmetric. I would say true.
I'd say true.
Sorry guys, I clicked on the wrong thing and I'm stuck.
That's okay.
Okay.
We'll wait.
Let's wait.
Wait, give you the answers.
And I'm confused. We're on lesson 5, right?
Yeah.
Yes.
But I'm just clicked on lesson 4. And did we already do 4?
We did
Yes.
for Tuesday.
So. Okay.
And we got 100.
Yeah.
Yeah, we
Amazing.
did well.
Yeah.
Well, it's saying that I haven't done this one.
Oh no.
Because I got 100 as well.
Yeah, I remember you got 100. We all got 100.
Yeah.
Maybe
Maybe email.
Yeah, hold on. This just tells you how many days it is.
Are we recording this?
Yeah. Or it was. I did click recording. It says it's recording.
It says live, so I don't know from my side.
Yeah.
Okay, so 5 group meeting.
Yes.
Okay, I'm here.
Awesome.
Okay, so 3. The total area under a density curve must equal...
1.
I'll be back in just 1 second.
below the x-axis. True?
That's
False.
And Alyssa, can you explain that again?
Tracy,
Yeah, help me.
Oh,
I'll go
Sorry.
see if I can find it in the book here. It was, she read it in the same sentence as the curve being 1. I think it's right up towards the top of the homework. I'm looking while she's waiting. Hold on here. Let's see.
So is a normal density curve symmetric? Yes.
Yes.
True.
Okay. So explain the number of
So-
squares.
At the bottom of the homework there, in the remember summary part, it
Okay.
says a normal density curve is symmetric and bell-shaped. The curve lies above the horizontal axis, and the total area under the curve is equal to 1. So it lies above the horizontal axis. What's the
Okay.
question?
What question did you guys get to?
We're on number 6.
Okay,
Yeah, so number 5 is true.
got it.
And 4 you got as false, right?
Yeah.
Yes.
Okay. Number
Thank
6,
you, guys.
which of the following elements of the figure represents the z-score in the image? It would be C.
Okay.
Correct. The following elements of the figure represents the probability that the random variable z will be greater than 1.
It'll be A.
Greater than 1.
So
Is
A?
it outside of it?
Well, the density curve equals 1, so that's confusing to me.
Yeah, this one's...
Represents the probability that the random variable z will be greater than 1.
I would say A, and I'll be the guinea pig.
Okay. Yeah, and if that doesn't work, I think it's none of these.
Yeah.
Okay.
According to the 68, 95, 99.7 rule, what proportion of the data from a bell-shaped distribution will be within 1 standard deviation? That's the 68.
Agreed.
Suppose random variable z has a standard normal distribution. Am I going too soon, or?
No, you're good.
Use the normal applet to answer this question. What proportion of the values from this random variable will be between -1 and 1? Give your answer as a decimal, accurate to 3 decimal places, e.g. if the answer was 0.389184, you would enter to the third, so 0.389.
Suppose random variable z.
Okay, so what are you guys getting here?
I'm not sure I understand the question.
Okay, I'm getting 0.317. And maybe I should
Are you
share
getting-
my screen.
Yes,
See
please.
if you guys agree with this.
But yeah, 0.4602. So 461.
Are you sharing, Tracy?
I'm trying to.
Okay.
Okay, can you see that? So my right by putting the z-scores at 1 and on the left-hand side a -1. So then the area would be 0.3173.
I've got to read the question again.
Okay.
Mm-hmm. Yeah, I think that's what it would be.
Yeah, that makes sense.
Okay, and so then we round it to 3 different places, right? So 0.317, or actually 0.317.
Mm-hmm.
That's how they've asked us to put it in there, right?
Yeah.
Yes.
Yes.
I got
Better
that.
put the 0 in there.
Okay.
So I have a question because my internet decided that I wanted to, well, not my whole internet, but just my screen wanted to freeze on number 6, 7, and 8. What did you guys get for 6, 7, and 8? I can double check the answers.
Okay, 6 we got C.
C. Okay. Was
No,
7?
C, as in cat.
Okay. Was
And
7?
then 7 we're kind of stuck on,
Okay.
because it's kind of a trick question. So we think it might be A
Okay.
as our first choice, and none of these represent is our second.
I kind of think none.
Should I go
And
with
then
none?
number 8 is 68.
68%. Okay. And then I got number 9.
Okay, Alyssa, what do you think of number 7?
Well, I don't know. It's kind of confusing for me as well.
I think you're right, though. I think it is none of them. Sorry, go on.
That's one we'll just have to hit one at a time, huh?
We each just pick a different one, right?
I don't know.
Yeah.
I think it's none.
Yeah, I think it's
Because
none.
if the data is supposed to equal 1,
If it's supposed to equal 1, yeah, I can see what you mean, because if it's supposed to equal 1.
in the density curves in 2.2 in our book, it says the total area under the curve equals 1. So are we able to come out of that curve?
Well, would B be greater than 1? Or...
That's a good point.
Say that again.
Would B be greater than 1? Like
I don't
anything
think-
after... That's
I
not...
think, sorry.
Oh, it's okay.
I think because it's under the curve, that it's got to equal 1.
Okay.
It's the stuff outside of the curve that's greater than 1.
Yeah.
So I just typed it into the applet,
Okay.
and nothing is greater than 1.
So nothing is greater than 1.
Yeah, so I'll be the guinea pig, and I'll choose the nothing is greater.
I'll click none because I think that makes sense.
Okay. Okay, so number 10, suppose random variable Z has a standard normal distribution. So this is the same question, except we're going at
Substitute.
2.
Okay.
Okay, so 0.046, because it's 0.0455.
0. Okay, I get what that's.
And it is, there's no
0.45.
variation there.
4, 5, yeah. So the next one would be 3.
Oh,
Okay, so this one says 0.0027. So we put 0.003.
So 0, 0, 1.
0, 0, 3.
0, 0, 2.
Yeah, but you'd round up so it'd be 0, 0, 3.
Right, but make sure you put the 0 point.
0 point.
How are you getting a 3?
because it's 2-7 at the end there.
Right, and in question 9, it asks us to, if the answer is 0.389184,
Oh,
you would
okay.
enter 0.389.
Right.
Mm-hmm.
Okay. I didn't have the right side clicked, so it's blue.
Okay, do you have the right answers in there now?
The last one's 0.003.
Yeah.
Okay. Look carefully at your answers to the last 3 questions. What do you observe? As the z-scores increase, the area between the z's decrease. The
That is
values,
true.
the values match the 68, 95, 99.7 rule. The probabilities double as you move from Z1 to Z2. They don't double.
They don't double.
Mm-mm.
So
They
it's
look like they
a-
match.
You think they match the 6895?
Yeah, don't you?
Or, well, as the Z-score increases, the area, I don't
it's
know.
smaller.
Because the area stays the same, right? It's just a matter of blue that's moving.
Right?
Mm-hmm.
So is that the middle answer, B?
68. The 68, 95, 99.
Yeah.
That's what we're saying, right?
Mm-hmm.
Okay.
You want me to read this one?
Sure, attack.
The amount of protein that an individual must consume is different for every person. There are solid theatrical ideas that suggest that the protein requirements will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. You guys see that. The population mean protein requirement for adults is 0.66 grams per kilogram, -1 times whatever D is. And the population standard deviation, is 0.07 grams per kilogram, -1, -1. Use this information to answer questions 14 through 7.
So Tracy, can you just put that into your spreadsheet or not?
Yeah, I'm working on it right now. But what? Okay, so what's the question on 13?
So what proportion of the population have a protein requirement that is less than 0.60 grams per kilogram, -1 times, and
Yeah, all
the
that yum
deviation
stuff.
would be 0.07, -1. Give your answer as a decimal accurate to 3 decimal places. Wow. Shoot me now.
The mean is 0.66,
0.66, yes.
and your standard deviation is 0.07.
Mm-hmm.
Yep.
So our X is 0.60.
Right, 0.60 is, well, they want less than. I'm not sure.
And then you divide that by 0.07, right?
Right.
Which would leave it at 0.06.
Does that need to be in here? And a muffin?
So I got 0.857.
Yeah, is it a negative?
I don't
No, it'd
think
be-
it
I'm
is.
sorry. No. Sorry.
It wouldn't be a negative 0.857?
Would it?
Well, if you have 0.6 minus 0.66, that's a -6, right? 0.06.
To do. Let me look at my equation.
Right, because what are we trying to find here? The z-score?
What portion of the population? Wouldn't that be the area?
Yeah.
You're right, yeah. So I think it would be a negative 0.857.
Right, so let me get it into here.
What does your spreadsheet say, Tracy?
My Excel spreadsheet?
Sure.
Yeah. It says negative 0.85714. So then if I plug that into the normal probability applet, the area becomes 0.3914. So is that our answer? 0.391?
Let's see. What portion? I think you need to take off one of your blues.
Take off one of the what?
One of the blues, because isn't it asking for...
Oh, yeah, sorry. Yeah, so it would be 0.196. So 19%. Does that kind of make sense to us?
Yeah.
Yeah,
And that's not a negative, right?
relation.
No, it won't be a negative. Not the area.
0.196.
Okay.
Whew, way to go, everybody. We'll see.
Yeah, we'll find out.
We'll see, but wow.
Okay, so what proportion of the population have a protein requirement that is more than 0.60 grams?
So then would you just click on the
Other side?
Yeah, I think so. And then unclick the left.
Mm-hmm.
Greater than.
Okay, so we get 0.804. How come I have a feeling we're doing this wrong?
You really?
No, but it just seems, I don't know.
That feeling is.
I know why. It's that time. It's 9:40.
Yes.
Okay, so what proportion of the population have a protein requirement that is less than 0.70?
So what that is saying.
You go 0.70.
Minus 0.66
Mm-hmm.
divided by 0.07.
Yeah.
And I get 0.571.
5714.
Yep.
So does that go in the area?
That in.
Yeah, and it's less, so it's on the less hand side, right? So 0.284.
0.285?
No, 4.
I got just 284. 0.284.
Yeah, that's what I got.
But if you put that in your... What am I doing now?
That'd be 28%.
What?
Right?
Mm-hmm.
Okay, I think I'm doing something wrong then.
What was your Z-score, Leah?
That's what I was doing wrong. I put my answer up in the area instead of in the Z-score.
Oh, okay.
So 0.284.
Okay, number 16. Find the probability that a randomly selected person will have a protein requirement that is between 0.60 and 0.70.
So is that the 0.804 minus the 0.284?
I think so. Here's our hint. Remember that you find the area between two values, shade to the left of each Z-score you calculate, and then subtract the smaller area from the larger area. Make sure your answer is positive. This is the probability that a randomly selected observation will lie between the two values. Give your answer as a decimal, accurate to 3 decimal places.
Yeah. I got, well, if I was doing it right, I got, I think, 0.520.
That's what I got too, but now I'm scared after reading all that crap.
Okay, so 0.520.
Mm-hmm.
That would be the first one, right?
Yeah. Thank you.
Or is that the answer?
I think that's the answer. Does Daddy have some for you?
So did you take the 0.804 minus 0.284?
Yeah, that's what I did.
Yeah, see, that's what confused me because the 804 is more than 0.60.
Daddy will get you
And on
one.
15, it's less than 0.70.
Right. Aren't you trying to get the area between? So greater than 60 and less than 70?
Oh, okay, so yeah, the 0.284 would be the same no matter what side you put that on, right?
I don't know. I wasn't playing with the chart.
So I got 0.52.
That's what I got too.
Perfect.
Put
Make
a
sure you put the
zero.
0 in there, though.
So 0.520.
Yes.
Okay.
Okay.
Okay, I'll just agree with you guys. I'm confused on that one. Okay, find the 35th percentile of the protein requirement for adults.
So do you put 35 in the area?
0.35. Okay, which one do you highlight?
I'm guessing. I don't know.
Stop.
So it would be the stuff on the left side would be your 35%, right?
That would be 0.35.
385.
935? Or would it be 940?
Now, where are we getting the 385 for the z-score?
So if you put in the area 0.35,
Yeah.
because you're trying to get the 35th percentile, is that right or wrong?
That's what I thought is you're supposed to put the 35 in the area. But where did we get the z-score from?
Down on the bottom left.
So it's a negative 0.385 or not.
Okay. So I did
so
it
you
wrong
just
the
put
first
the
time.
35 in the area, and then that was the number it came up with. I don't know why
Right.
that's like the third time I've asked you, and
That's okay.
it just
Well,
keeps confusing
So
me.
that
for
is 0.385.
Yeah, and my question would be is do we need the negative in front of it?
I think so because it's in the 35th percentile, so it's below. I don't know.
That's what I would think.
agree.
So put it in.
Mhm.
Yeah,
putting it in.
0.385.
The 85th percentile. No, 80th
80th?
percentile.
So it would be 0.842.
Mhm.
Or is it? Yeah, I guess it is. Because as I mess things up, it changed my area.
Or, well,
Yeah, negatives.
Not a negative.
Not a
it's not
negative.
negative.
0.842.
It's not?
No, because it's in the 80th percentile, which is over 50. I don't know.
So it'd be the middle column and the right column.
So explain that, why the middle and the right columns.
Well, right down the middle of your color would be the 50%. Right?
Mhm.
Just like if you were to section them in quartiles. So if you're at an 80%, you would have that middle one and the right one.
Okay, because it's more positive.
Yeah.
Okay. Gotcha. So it's 0.842.
Yeah.
That's correct.
Yeah.
Okay, here we go.
Let's see how we did.
Cross your fingers. Are we sure on all these? Okay, submitting.
I think we got 4, 5, 6, 7. We got quite a few wrong.
7, 9, 10, 11, 15, 17, 18.
Oh
Ouch!
boy. Ow.
Alright.
7. So 7 is not none?
So I guess 7 was B.
7 is B.
Ouch.
That
So I
does
guess
not
what
make
I was
sense.
thinking was right, but
I'm sorry. It doesn't
No,
make
it's alright.
sense.
And 9, 10, and 11 were wrong also?
Yeah.
Okay, so what did we do wrong on those?
Let's random variable Z. I know what it is.
What is it?
It's 68%.
Huh?
No, because the stuff between one standard deviation is 60%. 2 standard deviations was the 95, and 3 standard was 99.7, right?
Right.
So that's a 9, 10, and 11.
I'm guessing.
So you think that's what the answer is?
That's like
No, because it says
a portion of the values are in between 1 standard deviation negative and 1 standard deviation positive.
oh, gee, yeah. We clicked the outside and should have clicked the inside.
yeah.
Oh my goodness, I'm so sorry, guys. That's my bad. So it should be a 0.683.
Yep.
I need to see it.
And so the negative for the 2 would be a 0.955.
And do something of that.
And the other one would be 0.997.
Alright.
Yeah, sorry guys. That is my fault. I just didn't read it right.
Hold on to it. Come back up.
So,
Should have been between.
There we go. There you go. Now set it down.
Whoa. Okay. 15, 17, and 18 I got wrong also. Did I just mark those in there wrong?
What did you put?
For 15, 0.284.
That's what I've got.
that's what I got as well. So,
Oh, and you missed it, or?
Yes.
Hmm. So 15, 17, and 18?
yeah.
Yes.
But we got 16, right?
Yay.
So we're thinking right.
How's that possible, though? If you're subtracting 14 and 15 to get 16, how is 15 wrong?
I don't know.
Nice job.
I am not sure.
Alright, put it in that.
I wonder if maybe I don't know, they wanted to round, maybe 1285 or something. I don't know.
That's not rough. That's alright. Oh, Pat. Here, hey.
Maybe we didn't take them far enough, or what proportion of the population have a protein requirement that is less than 0.70. So 57142.
Yeah. Chloe, come here.
Yeah, I'm not sure what we missed on that or how we missed 15.
Hmm.
Well, it would be less than. Oh, I think I know how. Because it's less than 70, so the middle column and the left column should be highlighted. So that answer should be 0.716.
Okay.
On which one?
Number 15,
Should be what?
0.716. Because I only put the left-handed side on the normal probability output. And I should have put the middle one also.
Yeah, I don't get that.
You don't get what I'm saying?
No.
Yeah.
But how can 16 be right with those answers? That doesn't make any sense.
I don't know. I don't know. So number 17, find the 35 percentile of protein requirements for adults. What are we thinking about this, guys? Is it probably just not a negative? Or, well, number 18 is wrong also. Um, 0.842. Yeah, see, I don't think I understand those.
Can mommy do that? Yes.
You think we should just email the teacher or something, or what are you thinking, guys?
You probably could if. And it's getting pretty late.
Yeah, I think if we saw the answer, we'd understand it, but.
Right.
All right. Well, we figured out what we did wrong on the other ones. So I'll send her an email and see what she has to say.
Okay.
You guys okay if I take off?
Yeah, I
Thank
think we're
you,
done.
Stephen.
Thank you.
Have a
Yeah.
good one.
You guys
Sorry.
have a good night. No, don't be sorry.
You too.
It is what it is. I was the guinea pig.
Well, I should have been the guinea pig.
It all works out. Don't worry about it. I'm not mad at all.
Okay.
So don't worry about it, guys. Have a good night.
Good
All
night.
right. See ya.
Thank you for your help.
You're welcome.
All right. All right. I'm gonna hang up too. I'll send her an email and see what we did wrong.
Okay, sounds good. Have a good evening.
Okay. All
See ya
right. See ya.
Tuesday.